Hello, everyone, and welcome. It is Wednesday, August 11th, and it's time for the Topher Spin Knowledge Bolide Hangout. We have so much good stuff planned today. We have a special guest, Daniel Sheikh, classifier to the stars in the building.
To tell, but I did see what looks to be a couple potential chondrules, not that many, maybe a few. So if I had to look at this sample and make a guess as to what it is, I would guess probably an L chondrite, maybe some higher petrologic type, maybe a 5 or 6. But beyond that, I can't really tell since it's a little hard to see, but that would be my best guess.
While we're talking about 1AB meteorites, I have one show and tell that I want to show. This is a brand new meteorite for me. Pazanka from Russia. All right, there she is.
Oh boy.
Look at that. Pazanka.
A lot of big crystals there.
That's nice.
That's really nice.
And inclusions.
I absolutely love these inclusions that Daniel was just talking about. Look at how round that one is.
Oh
Yeah.
Almost too perfect.
Yeah. It's
like a bullet just got shot into it.
Yeah, it's a chondrule of metal, of sulfides. Yeah, this is my absolute brand new one. Look at that. Like, I literally ran out to the mailbox before the hangout today.
All right, so y'all seen this before. This is shale from but it's shale, so this is pretty cool. I was very happy to get this, but then Alan Mazer offered these are shavings from a core sample.
Oh.
So drill bit shavings.
Nice.
Cool.
Whoa.
Well, I guess one.
Oh, wow.
So I'm not opening it because it looks Topher, you can say your trademark wafer thin if you
Yeah, it's only wafer thin.
Right. It's got those layers, like those fingers there. Like you don't want to like open it up and find out that that's not all together.
Cameron,
exactly.
Are we actually looking at the thread cuts on that from a cord?
Yeah, I think so.
Wow.
That's what I think it is. So
that's amazing, buddy. Congrats.
Thank you.
Wow.
And then the other thing I have, if you want to play guess that species,
boy.
Ooh.
got a little bit of crust there. I think I heard the Aubrite, which he is exactly right.
Ooh.
We're playing Meteorite of the Month Club.
Right? Exactly. This is 1.6 grams of the nameless new Algerian Aubrite.
Just wanted to show off some of the stuff. I've been doing a bunch of cutting lately. So wanted to share some of the cut stuff.
Nice.
Obviously, you all just saw that. That was the Aubrite. So
you got your sample and cut it?
No. I cut everyone's samples.
Yeah.
So I was stoked to get asked to cut up the modem for this month. So yeah, that was what I was cutting up for a bunch of time.
That's fantastic.
So I believe it's a type 3. I don't know. I mean, we'll see when I cut it.
I'm thinking that's a Eurolite. Are we not on the same page?
If I would be surprised if this is a Eurolite, but I mean, if you look right there, and it's hard to see, but that big chondrule right there actually looks like a barred olivine.
Wow. Wow. Look, go back. Yeah, look at that little puppy right there.
Yeah.
Well,
I think this one's going to be a good one.
Yeah, I don't mind being wrong because there's no egos here. I went out on the ledge and I just assumed it was a Eurolite, but it is not.
Let me there we go. So that's the one that I think is you could see the like striations to it.
Yeah.
And this
Yeah, you can kind of see that.
the bottom part that looks like all dotted or like broken up. That's actually what it looks like. It looks like those same bars that go all the way through it are just broken into pieces. Like it was,
Polysomatic.
yeah, there you go.
Yeah. Thank you, Pat Brown.
You got me, Chris. I was thinking Urolite because I just cut one of those too. And that L had that kind of jagged, triple junction look to it that kind of like a Urolite has, which is what this is.
Mhm.
But obviously when you turn this one around and look inside of it, it's definitely got no chondrules in it.
Yeah.
But this one is, I'm interested to see, this is under classification. I'm interested to see what the write-up says about it. Because it's got some pretty cool little reddish orange crystals in there. And I don't know if you can see kind of up towards my my pointer
yeah.
finger. There's a couple of them there.
Mm-hmm.
You were talking about helping out Yang. Yang also sent some pretty cool stuff to cut up. So chopped up a bunch of provisional CO for him.
Very nice.
Bunch
Carbonaceous.
yep. And guess what that one is? Probably one of the rarer of the achondrites.
Wow.
This is one of 35. This is angrate.
Ooh, even more so.
Yeah, so I gotta check the Lodgernites. I don't remember what the total number of those are now.
Wow. No wonder why I have no idea what it is. I can't afford an angrate or a Lodgernite.
And I'm glad Yang is on here because he also sent a bunch of Mesosiderite to cut up.
Wow.
So I obviously did as he asked and halved all the individuals, and I'm glad he's here because I got those all halved up and they look good. And then I got to the last one, knew there was something good in there because about 3/4 of the way through, the saw basically stopped moving forward. And that last little bit took me quite a long time to go through. And so I knew there was gold in there.
Yes, look at that nodule.
Whoa.
Send me a picture of that, Mike, if you have the chance.
Certainly, yeah.
Awesome.
So yeah, I just etched this about 40 minutes ago.
Wow.
And there's the two
massive.
halves, and that had a nice,
That's
nice
gorgeous.
structure there for him.
This is from Chile. This is Los Vientos 262.
Wow.
It's an L6. And it's nice. It has brecciation. So a lot of the slices are nice and red on the inside and show brecciation. And I'm really thinking this is going to be a nice one once it's cut up. I do want to point out, because we always say air holes and bubbles and stuff are meteor wrongs. What we're looking at here is an eroded surface, actually. So there we go. My phone finally started working. So what you're actually seeing is just the eroded surface. There you can see more fresh fusion crust, but there it's more eroded away. So those aren't air holes. Those are softer materials being eroded away. That's what that is.
But I do have something. Maybe this is my first time showing something on camera, but I do have an interesting sample that I'd like to share with the group if that's possible.
Absolutely, buddy.
So unfortunately, I don't have it cut at the moment, but I have this meteorite right here. This is Uidsfayet, or Uidsfayet, however you want to call it. So this is an H5 fall from 2019 that I classified. It's my only fall, but basically this meteorite fell, I believe it was May 16th, and it took a couple weeks to recover. Yeah, this one I was actually fortunate to obtain from Noordin Zelmat. He was selling this piece online, and I asked him, if he was willing to sell it to me because I'd like to have a piece of it, since I didn't own any of this meteorite. And he told me he'd give it to me if I could help him out, get some stuff classified. So I helped him with about 3 or 4 classifications. So it's a very nice piece.
That is fantastic. How much is it? How many grams? Do you know?
About 160-ish. There's only about 2 point some kilos of it available. So
Yeah.
it's a very nice piece.
Wow, that is phenomenal. I'm very happy for you, and it's nice to see the meteorite community sharing and coming together for our strengths.
Mm-hmm.
I actually, Ued Saif is actually a meteorite that's close to my heart for one reason, for academic reasons. It's the first meteorite that I officially donated to ASU's collection. So they have Ued Saif. That's how I say it. They have it on in their collection. Not nearly as beautiful and big of a piece, but they have two individuals on in their collection from mine. I always surround myself with smart and intelligent people, and my goal is never to be the smartest person in the room, because then I stop learning. So at this point, I'm going to ask that Daniel Sheikh take the mic, and he is going to regale us. No, he has something that he wants to share with us about the MetSoc and his presentation there. And he has also some other information, and we'll basically listen to him as long as he talks. So I'm handing it over to Daniel Sheikh, and we're super proud to have you as a Knowledge Bolide crew member, buddy.
Thanks so much, Topher, and thanks to everyone else. Most of the people who had posters to present, they presented it in a unique format where everyone can type questions in and ask them, and they can answer them in real time, as opposed to if you go to those conferences and you see people presenting and there's like people passing through, and sometimes it's hard to ask questions because it gets loud, and it's much less of a hectic environment when you have these virtual sessions. So with that in mind, I presented my poster on an interesting meteorite. I'm sure some of you might have heard of it, called Errachidia 004.
Boom. Yeah.
It's a very unique Winonaite, to call it that, but this is exhibiting what's called a granoblastic texture, meaning that the minerals in here are roughly about the same size, and the minerals that this sample was made up of are primarily olivine and low calcium pyroxene. So we tend to call this an ultramafic rock. Another thing you see in this lithology is that you have these veins running through.
Yeah.
And most of these veins are either iron oxide or troilites. There's not much iron nickel metal in here that's fresh. There's maybe a couple specks right here, but most of this is troilite, which is an iron sulfide. The grain size of these silicates, you can't really see it too well. But when we move to the high metal sample, we can see right away that there are some clear differences. The first thing, of course, is that the grain size is different. So we can see right away here the grain size of these silicates, which are these darker contrast phases here. For reference, the metal is this very high contrast phase, and the darker phases are silicates. And so this meteorite in particular is very magnesium dominated. There's almost very little divalent iron in the olivine. So this access goes from FO, which stands from forsterite, which is just the magnesium-rich end member of olivine, all the way to phaolite, which is the iron-rich end member of olivine. And we can see that both the low metal lithology, which is this one, this was the only one that contained olivine, plots all the way pretty much where the end member forsterite is. So basically there's almost no iron in this olivine. See, these points plot all within that group. So in terms of its silicate mineralogy, both of these lithologies are technically part of the Winonaite meteorite group in terms of their silicate mineralogy. But what's also interesting to note is that even though the textures are different, the metal content's different, and the grain size is different, and even the relative abundance of these minerals are different, why are their chemical compositions the same? And this will sort of be tied in at the end with the conclusion, but keep this in the back of your head, why they're the same, why aren't they different? You know, I mentioned they were polymits. Shouldn't they be different, but they're not? And that I'll explain in a bit. And just in case to determine something else about this sample, I wanted to determine what the metal chemical composition was, because the high metal lithology contained a lot of metal. So I figured, what if you extracted some of that metal and you ran it to determine what kind of elements were in there and what that could tell you. So a colleague of mine, which we actually just talked about, Dr. Chris Hurd, Him and his graduate student, Patrick Hill, they did ICP-MS analysis of the sample of metal grains extracted from this lithology. So they actually removed metal grains and then they dissolved them and then they ran them to get chemical compositions. This is plotting on the bottom right here. This is just the raw data values of siderophile or iron-loving elements, meaning they fall within the metal. And this is just their concentration. So this is just saying that there's 7.4 weight percent of nickel, 0.3 weight percent of cobalt, and then you have all these other trace elements. For example, these are highly siderophile elements and some other elements. And why this is important is because I don't have the graph here, but iron meteorites are divided into, I think, 17 to 18 groups by chemical composition. And this is mainly determined by these elements right here. So that's why when you're trying to figure out what kind of iron meteorite you fall into chemically, it's important to get these elements because otherwise you can't do that. Mm-hmm. So what I likely think occurred was that this lithology formed immediately after the first impact event. So you had impact of the body, metal from the liquid metal from the core was disrupted and mixed in with a basaltic partial melt from the crust. And that formed this high metal lithology. Then the question is, how do you get this lithology to be mixed with this lithology? And also, why does this lithology not contain, relatively high amounts of metal like this one? Why is it almost absent of metal? And I think that's because there might have been potentially a second impact event that further mixed other material in the crust with existing material that already incorporated metal from the previous impact event that had later cooled. So it's either that there were two impacts that occurred on the parent body, which
awesome. So Damian, as you guys know, does phenomenal photographic work. And he is taking us for a ride today through his Antarctic samples. But just look at this, these chondrules that he has, just amazing.
That's why I'm thrilled to have not one, but two such samples. Both I got from Alan Mazur, and both are actually historically significant. Teal Mountains from 1961 was the first Antarctic pulsite find and only the third meteorite found on that continent, out of 45,000. It's also one of the finds closest to the South Pole. It's just an ordinary L6, but like L'Aigle, very significant in the history of meteoritics. And now the wonderful Teal Mountains pulsite. It's a gorgeous micro with both metal and olivine parts.
Beautiful.
Looks like fire.
I know.
If that's possible, the other side is even more beautiful. Now from hot deserts, let me show you a few more macro shots from my probable L3 slice. I still can't believe how perfectly this unusual chondrule symbolically illustrates a fiery meteor. The colors are perfect. You can even observe the oriented shape, flow lines, roll over lip, and in-flight fracturing and breakup. The similarity is truly uncanny.
I love you, Damian. That is beautiful.
Here you can see an obvious lunar inclusion. Now, how did a hard-boiled egg end up in this beautiful glossy contour?
Andy's a comedian.
Yeah, I love it.
Okay, enough bad jokes. I'll shut up now and let you enjoy the rest of the macro photos.
Marrera. Well, it's an L6 that was witnessed in December of 2012 in Mauritania.
Oh, yeah.
Look at the
That
frothiness right there. So this is an L6. But this is going in my private collection under the gifts. Look at that. Really see the detail in that fusion crust there.
That's a key. Well, this is I had a bunch of chondrites for ever since the beginning of last year. Some of them I bought from Matt, some of them I bought from you, some of them I bought from Sean Cache. And this was one that I was really, really just in love with. Looking like an H5 shock of 2. Weathering is pretty low, but it's gorgeous looking stuff.
Yeah, I love these white chondrules right here. There's 2 of them, and then there's a dark one right there. Yeah, it's beautiful stuff. So I appreciate that. This is super cool. Man, we had a great, amazing hangout today. Thanks so much for everyone, especially a big thank you to Daniel Sheikh, our resident scientist. Yeah. And everyone who showed off something, thank you very much. We're going to continue the hangout without being recorded because we're going to get into some good stuff now. So check us out live next time. Have fun, guys.
Have a good week, everybody.